Hello class and welcome. In lesson 3.5, Properties of Logarithms, you'll learn to use the properties of logs to condense or expand a logarithmic expression. Now, similar to exponential functions, logarithmic functions with base a have a log property that kind of corresponds to exponents. And the reason for that is because since logs are inverse functions to exponential functions, they have properties that are similar to that of the logs. And just to review, exponents. So just to review a couple of the exponent properties, they have your power property. If you multiply two powers together, you can simplify that or condense it into one base by adding the exponents. If you're dividing two exponents, exponential expressions, you can condense this to one base a by subtracting the exponents from each other, as you see in this example here. And then you have your negative power property and the power of a power property. Well, logs have similar properties to this that kind of correspond to these properties here. The first property we're going to discuss is the product property, which states that if the log base b is multiplying two values, we can expand this to two separate logs of the same base by adding the log base b of x with, in this situation, with the log base b of y. Now, if it's a natural log, specifically with a basis e, we can apply the exact same property. So the natural log of x plus the natural log of y equals to the natural log of x times y. Now, when we change the logarithmic expression from this to this notation, this is called expanding it, because you're obviously expanding the number of logs and increasing the number of logs from 1 to 2. And when you go from the right to the left, that's called condensing it. So this is the expanded form. And this is the condensed form on the left. And that's going to be the notation for every single one of these examples for the other properties that when we discuss. So for this example right here, to condense this into one log, since I am adding again these two logs, I condense it to one log by multiplying the 3 with 7, which is a total of 21, not 27, but 21. So this is the condensed form of log base 4 of 3 plus the log base 4 of 7. We get the log base 4 of 21. To do this example, same situation. We have the common log of 3 plus the common log of x minus 5. So the condensed form would multiply again 3 with x minus 5, which is 3x minus 15. So this is your condensed form. One last example here. To condense this using natural log, same idea. We're simply going to multiply 3x with 3xy, and that's going to give us a total of 27x to the second power times y. So we have the natural log of 27x squared times y. So this is the condensed form of the natural log of 3x plus the natural log of 9x times y. And there you have it. Now the next property, now let's go in the opposite direction. Instead of, before we move on to the next property, let's go in the opposite direction to condense, to expand it. Well, in this situation, it's not clear what two numbers are being multiplied here, but since we have 15, this has an infinite number of possible right answers. So since 15 can be written as the product of, let's say, 3 and 5, that's the easiest ones to think of, we can expand this by giving 3 its own common log, giving 5 its own common log, so writing the log of 3 plus the common log of 5, and the expansion form will simply add these two quantities together. Our next example is also a little tricky one right here. We don't know what two things are being multiplied here, but in this example, because we have x squared minus 9, that is a difference of squares. So if I write x squared minus 9 as the product of x plus 3 and x minus 3. Again, this is just factoring this into the difference of squares. Then we can expand this to the natural log of x plus 3 plus the natural log of x minus 3. So as you can clearly see, again, the idea here to expand it is just to identify the two things that are being multiplied together in order to give each, in this situation, factor, give each factor its own natural log, and then add those natural logs together. Now to expand this one, well, the two things that are being multiplied here are 15 and x to the third. So to expand this, I would give each one of these, I would write this as log base 2 of 15 and the log base 2 of x to the third. And again, just worrying about, again, our product rule, we expanded by writing log base 2 of 15 plus the log base 2 of x to the third. Now 15, again, we could expand 15 because 15 is technically the product of two values, but we won't. We'll leave it like this and not find two factors of 15 because, like I said, there's an infinite way to get 15. We can use, again, 3 times 5. We can use 1/5 times 45. Yeah. Oh no, that doesn't work out. 65. 1/5 times 65, that's another possibility to writing 15 as the product of two things. And like obviously 3 times 5, we mentioned that one. So there's an infinite possible ways of writing 15. So we're not going to worry about all those different ways. So we're just going to leave it as 15. But this would be the expanded form. So just recognizing again that you're multiplying two things and then give each one of those factors, those, in this case, these two factors, their own log base 2, which I forgot to write the 2 right here, and then add them together. So that's expanding. Now let's move on to the next rule. Now we can move on to the next property. The next property is the quotient property. So if we're dividing, again, x and y instead of multiplying, we can expand this by writing the log base b of x and subtracting this time by the log base b of y. And the same thing is true with the natural log. The natural log of x over y would be natural x minus the ln of y. So let's look at some examples of these. So right here, the ln of 45 minus the ln of 3 in a condensed form will simply divide these quantities together. And that's a total of 13. Sorry, 15. (45) divided by 3 is 15. And there you have it. So this is a condensed form for that. For things, again, that are not just integers, like in this next example, we would, again, condense this by writing the common log of 12x to the 5th divided by 4x to the 3rd. And in this situation, we will divide and end up with, well, 12 divided by 4, that's 3, and x to the 5th divided by x to the 3rd subtracts those exponents, and we end up with x squared. So the common log of 3x squared. And for our final example, again, same situation. Here we have the common log of square root of 72 minus the common log of 9. So that would be the common log of 72 divided by 9. And they're both inside the square root, so we can just write it as the square root of the quotient of that, which is that's 8. And that simplifies to the common log of 2 radical 2. So that's the simplified form of this. Or I'm sorry, the condensed form of this. Now going in the opposite direction to expand this, we just need, again, this is easier to see because we can clearly see that we're dividing 3 by 4. So dividing 3 by 4 expands this to the log of 3 minus the log of 4. So this would be the expanded form. And again, it's clearly to see when it's expanded, when it's condensed, because obviously expanded means you have more logs. Condensed forms, you have less logs. You have 1 log. So the expanded form of this is the natural log of x plus 3 minus the natural log of x plus 2. And on the last one, well, 4 isn't being divided by anything unless you want to read this as the natural log of 4 over 1, which with a condensed form would then be the natural log of 4 minus the natural log of 1. So everything can be written as that. But if we think about 4 as, let's say, 36 divided by 9, then the expanded form of 4 would be the natural log of 36 minus the natural log of 9. That again would be the expanded form for this. And there you have it. Now the last property is called the power property. Now this one is kind of weird because on the other ones we see the expanded form gives us more logs. On this example, on this property here, we don't have more logs when we expand it. The expanded form to this property puts this exponent to the front of our log. So we have the log base b of x to the n power. The expanded form of that would be the n multiplied with the log base b of our value x. And for the natural log, the same thing. The expanded form would be n times the natural log of x. So this one's kind of weird to say that we have expanded it, but technically this is what we refer to as this as the expanded form using this property. And the other way around, this would be the condensed form of this. So let's start by condensing situations like this. So let's say that we have 3 times the log of 6. To condense this, this is going to pull this number up here to make it an exponent, and we have the log, the common log of 6 to the 3rd power, which when we simplify is equals 216. So the log of 216. The condensed form for this is the natural log of 4 to the x power. And the condensed form for this is the log of base 9 of 49 to the 1/2 power. Now I'm going to give you a little reminder here that 49 to the 1/2 power, or anything to the 1/2 power, let me just write a general rule instead of this specific rule, anything to the 4th power, to the 1/2 power, is simply the square root of that value. So here, this is technically the square root of 49. And well, the square root of 49 is 7, so we have the log base 9 of 7. Now, to expand it, we then now pull the exponents to the front and multiply by the exponent. So here it doesn't look like we have something to the exponent, but you recall again what we just wrote in the previous slide, that anything, if we take the square root of something, that's equivalent to getting that value, that base, and raising it to the 1/2 power. We basically have a square root is an exponential expression with a rational power, and specifically the rational number is 1/2. So because we're taking the square root of x minus 3, technically that's this, well, equivalently, better word, equivalently, that is x minus 3 to the 1/2 power. And now to expand this, we simply pull this exponent to the front and multiply by 1/2. So the expanded form would be this. The expanded form for this pulls that x to the front. And we have x times the log base 4 of, log base 5 of 4. And for this one, here's a tricky one. We don't have 1 over 9 as an exponent, but we can. Remember, 1 over 9, first of all, can be written as 9 to the negative 1 power. So we can rewrite this as that. Or, and since 9 can be written as, let's say, 3 to the second power, excuse me, I can write 1 over 9 as 3 to the negative 2 power. So let's use that. But this has multiple correct answers, okay, because there's various ways to write the number 1 over 9 with an exponent. So if we use this substitution for 1 over 9, I can expand it by pulling this exponent to the front and getting this. So this one, again, has an infinite number of possible answers, or has multiple, not infinite, but has a multiple of correct answers. And we end up writing negative 2 times the natural log of 3. That's one possible correct answer. Now, to apply multiple properties in order to condense and to expand, well, we have to, again, follow these properties in the following order. We first want to use, again, to condense, first want to use the power property, and then after using the power property, we'll then apply either the product property and the quotient property from left to right. So here, the power property will move this exponent here, will move this exponent there, and we have this. Now, before I apply the quotient, the product property, because I'm going to simplify some things here. This to the second power x to the third, y to the second power means we have x to the 6th and y to the second. Doing the same thing on this other log gives us x to the 4th and y to the 8th. Now I will apply the product property. Since I'm adding these two logs, I can condense it by writing it as one common log and then simply multiplying this with that. And multiplying that's going to simplify to x to the 10th and y to the 10th as well. Since I'm multiplying x and x, I add the exponents, multiply y with y, I add the exponents, and we end up with this. So this would be the completely condensed form of that expression up there. So let's do another one. So again, the first property we're going to apply in order to condense this is first apply the power property. So here we would raise this to the 1/3 power, 3 over 2 power, and we have the natural log of x to the 3 over 2 minus the natural log. I'm going to, again, move this over here, and 16x squared is going to be raised to the 1/4 power. So let's do some simplifying on this second one here. Let's figure out what this to the half power is. Well, 16 to the 1/2 power, that's a total of 2. And x squared to the 1/4 power, not half power, 1/4 power, 16 to the 1/4 power is 2. And x squared to the 1 power multiplies those exponents. So 2 times 1/4 is a half. Now to condense this, I will then now apply the quotient property. So if I use the quotient property, this condenses it to 1, and it divides x by 2x to the 1/2. And now simplifying that answer, we simplify by by dividing the exponent, the x's. So we have the 1/2, 1 over 2. That's from 1 divided by 2, 1 over 2. And this is going to subtract those exponents. So 1 minus 1/2 is 1/2. And if I want to use again the equivalency of raising something to the 1/2, I can leave it like this, or I can write it as the square root of x, since that's what it means again. To have x to the 1/2 power means I'm taking the square root of that. So I can write my answer like this, leave my answer like this, or I can write the equivalent value of this. Either case, both of them are correct, okay? Now, if I want to expand logarithms and go in the opposite direction, well, the procedure here is to first now go in the opposite direction and first apply either the quotient and power rule, so my power and quotient rule from left to right, and then apply the power rule. Sorry, I meant to say product rule over here. So I want to start by first using either the product rule or the quotient rule, again from left to right, whatever I see first, and then I will apply the power rule second. So to expand this, notice that we have three things. We have x to the third, we have this cube root of y, and we have w to the 6. So that's going to give me 3 logs. Well, 3 natural logs. Okay, so I expanded using again product and quotient. Now, because I'm multiplying these two, that's going to add those two quantities together. And since this is being divided by this, that means we're subtracting this quantity down there. So we're subtracting the last natural log. So I have given every single one of the logs its own each one of these factors and quotient its own log, and now I can apply the power rule by moving these exponents to the front. So we have 3 times the natural log of x, 1/3 times the natural log of y, and then 6 times the natural log of w. And the 1/3 again I didn't mention this, but the 1/3 again I got since x to the 1/2 is equal to the square root of x. X to the 1/3 means I have the cube root of x. It's just again the same rule, just changing the exponent from 1/2 to 1/3, because that's what the index is on the root. It's 3, so it's 1 over 3, while here the index is a 2, so and it's 1 over 2 because of that. So let's do another example. So in order to condense this, again, notice that I have 3 things. So I'm going to have 3 logs. So I'm going to expand this to 3 logs. I have the log of 3 to the x. I have the log of w, and the log of y to the 3rd. Since I am dividing by w and y, that means I'm going to subtract those respective logs by the quotient property. And now by the power property, I simply pull those exponents to the front. And we have this. So this is the expanded form. And there you have it. So this concludes again the examples on how to apply the logarithmic properties to expand or condense logs using these properties. So again, like always, I appreciate you watching, and I hope you have a great day. Well, I'm sorry, if you do have any questions, do not hesitate again to send me a message on Remind or through email. And like always, thank you for watching, and I hope you have a great day. Goodbye.